Hello.
I'm very happy to introduce the speaker of this session, Professor Ayman Badawi from American University of Sharjah. He will talk about some results on annihilator graph. Professor Ayman, please start.
Well, thank you very much, and I thank you for organizing such conference. I know this takes a lot of time, and I'm happy to be with you on this occasion. I've been in Iran 3 times, by the way. I I know some colleagues in Iran. You know, one of them, maybe all of you know, Saeed Akbari, and others. You know, Simak. I know Yusufani, Ahmed Yusufani, and others. Anyway, so I'm gonna share with you for 20 minutes different type of the graph. This is a class of the graph. Uh, we uh, we attach a graph to a ring. So this is the talk I will be given here. Okay, so let me start. As usual,
Dear Professor Ayman, please do larger your screen,
larger.
please.
This
And yes, it's good.
is good.
Yes.
Okay, all right. So in this talk, my ring R will be commutative with non-zero identity, and ZR will be the set of zero divisor. I take you back to 1999, a paper by, well, in fact, before 1999, I put the three names together. In 1988, Bach, he initiated the idea of zero-divisor graph. But he defined it, he was, interested in coloring the ring. Uh, the official definition started in 1999 by Anderson and Livingston. And so what is the definition of the zero-divisor graph? It's a symbol graph with vertex set. You take all non-zero zero-divisor of R, and two vertices are connected by an edge if and only if uh, you know if and only if the multiplication is 0. Okay, all right. uh, in 2014 I introduced a graph called Anihilatory Graph. And what is Anihilatory Graph? Is also undirected symbol graph with the same set of vertices. The zero divisor of R takes 0, and two distinct vertices are connected by an edge if and only if the annihilator of xy is not equal to the annihilator of x union annihilator of y. Okay, so you know what I mean with annihilator. Annihilator mean you take all the elements in R that kill x, y. So the annihilator here, I define it here. The annihilator of M, all the elements in R where ym equals 0. Okay? In 2017, Maybe I will not have time to talk about. There are three Iranian mathematicians who introduced uh, another graph that is related to the annihilatory graph called extended zero-divisor graph. And the definition, it's the same thing, the same set of vertices, but we change the condition that two vertices x and y are connected by an edge if and only if Rx intersection the ideal generated by x intersection the annihilator of y is not zero, or the ideal generated by y intersection the annihilator of x not zero. Okay, so I'm going to give you some results about the annihilatory graph. And please, Mohsen, whenever my time is up, I stop. Because I'm not sure how. Okay. Since I'm going to make use of your time, remember that the annihilatory graph, the set of vertices are all zero divisor of the ring, but take away zero. And two vertices x, y are connected by an edge if the annihilator of x, y is not equal the annihilator of x union the annihilator of y. Okay? So the first result, if R is reduced commutative ring, reduced means zero is the only nilpotent element of the ring. And we assume that the annihilatory graph is different from the zero-divisor graph. Then the girth of the annihilatory graph will be 3. Okay, and then you can read the rest of the result. Then I go to the next slide. Here is an example. If I take the ring easy one, Z8, then 2, 6 will be an edge in the annihilatory graph of R. That is not an edge of the zero-divisor graph of R. And you can see that 2, 4, 6 is the only path in the annihilatory graph of from 2 to 6. And this is also a path in the zero-divisor graph. The annihilatory graph of this ring will be K3. Of course, here, usually in many books, you write the index down. Here I wrote it up. And the zero-divisor graph is K12. This means, K3, by the way, mean complete graph with 3 vertices. This means complete bipartite graph. And the girth will be infinity. The girth of the annihilatory graph is 3. The diameter of the zero-divisor graph is 2. The diameter of the annihilatory graph is 1. And here are other examples I have. Okay. So here is the result. Like if you have a commutative ring and you assume the annihilatory graph is not the zero-divisor graph, then we know something. Then we know the girth has to be 4. The girth of the annihilatory graph has to be 4. I mean, the following are equivalent. I go down to the number 5. So if the annihilatory graph is not equal to the zero-divisor graph, and you tell me that the girth of the annihilator is 4, then I know the ring structure of R. R has to be ring isomorphic to these two rings. That's it. And this is one reason we study graph attached to rings. Why? Because sometimes you get some properties about the ring. Like, look at this result here. The only condition that I have the annihilator is not equal to the 0. They are two different graphs. Number 1 and 5 are equivalent. Okay? All right. Also here some properties about the annihilatory graph not equal the zero-divisor graph. Then I know that the girth of the annihilatory graph has to be, the girth has to be either a triangle or a square. This result by 3 Iranian mathematicians, let R be a ring, of course, commutative ring, and assume the annihilatory graph is complete bipartite. Then the annihilatory graph is complete bipartite if and only if one of the following holds. Nil of R equals 0, and the number of the minimum and prime ideal is 2. Nil of R not equals 0, and either the annihilatory graph is K1n or the annihilatory graph K23. Okay? Here is another result by the same 3 Iranian mathematicians about the annihilatory graph. Has to do with you know, like we know bipartite. Then you're gonna ask when it will be tri-bipartite or things like that. So if your ring is a product of integral domain n up to n, like d1, you know, dn, and all of them are integral domain, then the annihilatory graph will be n. Of course, here choose the ceiling n over 2 bipartite graph. This is a nice result. So you have, like, you know, a structure for the annihilatory graph. N choose the ceiling n over 2. Okay? How am I doing on time? Shall I stop or I still have time?
You have about 2 minutes.
Okay. Here is another result. If the ring is reduced, that is not integral domain, then the following are equivalent. The annihilatory graph is complete. The zero-divisor graph is complete. R is ring isomorphic to this. Again, here is another result where the connection between a graph and the structure of the ring. And for many of us algebraists, we are interested in a graph from our point of view, so we have some information about the structure of the ring. Okay? And this is a last result I will share with you. And you know, this talk is in a paper that's published, maybe, you know, but I never gave a talk about it. Well, maybe I did once back. Anyway, if you are interested, you can always email me, and I will be happy to send you my papers on a graph. And I thank you very much. And I stop here.
Thank you very much, Professor Badawi, for your presentation.
And I really want to thank you very much for, this is wonderful to be connected again with my colleague in Iran. And I wish you, all of you, best luck.
Thank you. Any questions?